Hello, in this video I'm going to go through a little bit of background of Wolfgang Pauli, one of the big names in quantum mechanics and particle physics. So Pauli, who was born at the beginning of the 20th century, and he was active throughout the first half of the 20th century. You see there, he died quite young in 1958. He was born in Vienna. He was the son of a chemist, and it was a fairly well-to-do family that he was born into. They were a Roman Catholic and Jewish family. Pauli was raised as a Roman Catholic, but they had some wealth. They had connections. I mean, his middle name was Ernst, named after his godfather Ernst Mach of Mach speed fame. So they certainly had some connections. He wasn't just some guy off the street. He in his academic career, I mean, he moved around quite a lot of different universities in Europe. He was professor of the university at the University of Hamburg in the 1920s, and it was during that period that he developed the theories that he was most famous for. So this is well, the exclusion principle, so Pauli exclusion principle, and spin theory that's related to. So if you recall your particle physics and you think of the standard model of particle physics, we've got this, we more or less categorizing these particles based on the properties of these fundamental particles. And we had the particles with half integer spin, which are called the fermions. And then there's the particles with integer spin, which are the bosons. And it was noticed that these particles behave very differently to each other. And this is spin not in a mechanical, a classical mechanics point of view, what we'd describe as spinning, like a spinning top. This is very much a different use of the word spin in the context of quantum mechanics. So spin theory then, it's describing the differences in the behavior of these particles based on the quantity of spin that they have. And then Pauli was the guy who then came up with the description that for these fermions, these particles with half integer spin, they obey what is now known as the Pauli exclusion principle, in that you can't have two particles occupying the same quantum space. Quantum state, I should say. So this is what means that fermions, this is why fermions take up space, and fermions create the solid matter around us, whereas bosons don't. Fermions have a structure in the way that they're arranged, in the way that bosons don't. The Pauli exclusion principle is fundamental to our description of actual matter and stuff that you can pick up in the world around you because of spin theory. So in his personal life, he went through a bit of a crisis at the end of the 1920s and the early 1930s. He got divorced, his mother committed suicide, and he ended up starting a collaboration with the psychotherapist Carl Jung in 1932. And there's relatively famous series of letters that the two wrote to each other, where Jung was analysing Pauli's dreams, and they were trying to, between the two of them, create some kind of philosophical, scientific interpretation of what was going on. And then, of course, not long after that, we had the Second World War turn up, and like many others, particularly those of Jewish heritage, such as Pauli, he ended up moving to the US for the duration of the war. After the war, he returned back to Zurich. I mean, it was in 1945 that he was awarded the Nobel Prize for the exclusion principle. And he had moved back to Zurich at this time. But it wasn't long before he then fell ill with pancreatic cancer, which obviously doesn't have a great prognosis nowadays, and it certainly didn't back then either. He was, I suppose, famously commented on the fact that he was in a room at the hospital, which was room 137 in the hospital, and he remarked how this 137, he'd spent a lot of his career puzzling over the fine structure constant, which has got a value of around about 1 over 137. This fine structure constant is it's a part of quantifying the strength of the electromagnetic interaction. So it is a core part of quantum electrodynamics and various other parts of particle physics. And yeah, it was something of an irony to him that this number that he'd been puzzling over for much of his career ended up being part of his hospital room when he was dying. He did work in the early part of his career with Max Born, who was one of the very early forerunners of quantum mechanics. And yeah, I mean, Born considered him Pauli to be comparable to Einstein in terms of his ability and his impact. So he really has a substantial both impact and legacy on particle physics, quantum mechanics. This transition into modern physics that we've been talking about, away from the classical physics and into the 20th century. So yeah, he really is one of the big hitters, not just of modern physics, but yeah, physics just entirely. So yeah, certainly someone worth knowing about.